Hi, my name is Russell, and I enjoy teaching computer science. I self-taught myself AP Computer Science in ninth grade and received a 5. Since then, I've been teaching with my school, particularly with the programming club, for 4 years, and I've taught classes ranging from 1 person to 10 people. When I teach computer science, I tend to teach with a technique slightly different from what you get online from places like Code Academy. Rather than teaching you the actual things to type, the syntax, I tend to enjoy teaching the semantics first, the ideas of thinking, before then transitioning and linking the semantics to the syntax. Hi, today we'll be talking about recursion. Well, when we program, we sometimes want to express repeatedly doing a similar or same action over and over again with a minor change each time. One way of doing this is by iteration using loops. So, easy example, just the for loop, which will go from 0 to 10, 0 to 10, yes, and simply print out what it does 10 times. Print out the the value it's on each time. This is one way of doing it, but the problem with using just standard iteration with for loops is that there's a lot of numbers we have to keep track of. We have this I equals 0 and I is less than 10. But the problem is, what happens if we say I is 1, if we want to start from printing 1, and we want it to print till 10, we want to print 10 times, sorry, then we would need to say I is 1 and I is less than 11. So we often end up with these off by 1 errors. So the for loop, unfortunately, has a lot of numbers we need to kind of remember, which makes it a bit more complex to work with. Another technique we can use is called recursion. At first, recursion is kind of conceptually a little bit more difficult to pick up, but over time, it really is a far more expressive technique. So let's look at some basic recursion. Recursion in computer science is very similar to recursion in mathematics, sequences and series. We simply take a function, repeat the function, with accumulating slight differences over time before finally doing whatever we need with the end result. So we'll write a basic bit of recursion which does the same thing as above, the for loop. So we'll say func print nums, and what it'll do is it'll take an int I and simply call itself, and if I is less than 10, then call itself again, but with 1 greater value. Otherwise, it will simply, we'll say, it'll simply return I, and finally afterwards we'll do the call on 0. So this will actually do the exact same thing. This recursion plus the call will do the same thing as the for loop. But the nice thing about it is we can actually change our values much easier. So if we want to start from 1, we start from 1. Start from 0, we start from 0. If we want to change our values, we change it, the highest number, we change it over here. There's no need to really think about iteration and the printing at the same time, because each value is encapsulated at a separate level, at a separate place, so it kind of gives it a better description of what each value, 0 and 10, mean. So anyway, so let's look at the actual semantics, the actual kind of necessary components for writing a recursive explanation of some repeated action. So first of all, you need a function. In programming, in computer science, we usually represent recursion by a function. So we have a function defined with the value that is going to be accumulated over time. In this case, we're calling it int I. Then we have our kind of check, the check, and if the check is met, then we have a recursive step where we call itself, but with some minor change. And then we have, at the very end, if the check fails, our termination. So we'll write this in general terms. In this case, we actually wrote our check slightly differently how you usually write it. Usually we'd write something like this, func and then instead we would say step and then if condition is met, then simply return the value. So this is how we'd usually write it in general. It's not too hard to understand. Anyway, so now that we kind of see the general way that we can write our recursion, let's look at some examples. So the standard one we'll talk about is Fibonacci. It's a rather useful expression. To do Fibonacci in for loops is a rather complex process, and so we won't do it because I don't trust myself not to make a mistake on video. So instead we'll represent it in recursion, kind of to demonstrate just how expressive recursion really can be. So let's first look at the Fibonacci sequence. Fibonacci sequence is a sequence of numbers defined at the value I. So the fib of I is simply the fib of I minus 1 plus the fib of I minus 2. So it's the some Fibonacci number at index I is the sum of the two previous Fibonacci numbers. So we start off with 1, 1, 2, 3, 5, 8, 13, etc. So let's just write this now in recursion. It shouldn't be too hard. Well, what we first need to do, we first need to describe our we first need to write the function. So okay, func fib of, and then we have the value that's changing. So we'll call it accumulator. Next, we need to have our step. Well, what is the step? Perhaps we need to encapsulate it in a check first. So, well, what should happen? It should keep adding the stuff below it, right? So we'll just write that first. Ac equals the fib of ac. Oh, sorry. We need actually two values, an index and an accumulator. Int index and accumulator. So we'll say ac equals the fib of the index minus 1 and plus the fib of the index minus 2. That's correct, right? But so what will happen now? It'll keep going down and down and down until we end up with indexes that are negative in value, which obviously makes no sense. So we do need to check that. We need to check that indexes are greater than 0. If the index minus 2 is greater than 0, because that's the lowest value we're ever going to reach, is greater than 0, then we need to run this. Otherwise, what do we need to do? Well, if it's greater than 2, if it's less than 0 at the lowest value we're going to ask, then it should resort to the base case, right? It should return this initial value that we started with. So then, otherwise, return 1. Oh, sorry, otherwise, return 1. And we'll see why we need to do this later. 1, and then finally simply return accumulated. And then we would do the call by saying fib of the accumulated start from 0 and index 10. So this would be the fib of 10. So this is actually fairly easy to read. Literally, so long as we're not going negative indexes, the value we're going to talk about is the value previously and the value to previously, and that's the value we're going to return. And we have this else bit right here to simply, as we go down and down and down, to do our base case for when it finally makes no more sense to really start adding down and down and down. So that's recursion. Hey, thanks for watching this video. I hope you learned something, and I hope I can work together with you soon.